Hi, this is Shannon Seaver. Today we are looking at the first part of section 5.1. We're looking at prime and composite numbers. So first of all, what we want to do is determine divisibility, and then we're going to write prime factorization of a composite number. Here are some definitions that you need to do, so you might want to stop the video after I'm done talking here and write these down in your notes. First of all, number theory. Number theory is a study primarily concerned with properties of numbers used for counting. Natural numbers. Natural numbers are the set of counting numbers represented by a bold N, starting with 1. It doesn't count 0, it starts with 1. So 1, 2, 3, 4, 5, and so on are all natural numbers. They're whole numbers. Factors. Natural numbers that multiply into a product. So for instance, 2 and 3 are factors of 6 because 2 times 3 equals 6. Some more definitions are divisible. A number is divisible, a number A is divisible by B if the operation of dividing A by B leaves a remainder of 0. So for instance, 24 is divisible by 8. 24 divided by 8 is 3 with no remainder. You could also say that 8 is the divisor of 24, and 8 also divides 24. Another way to write divisible is B, and then you'll see this vertical line A. So that would be the same thing as saying B divides A. So one of the things that you need to remember on this page is all these bold items on here. It's very easy to get them mixed up because they all have div as part of the root word, and so you just really need to make sure that you understand that for a test. This is also important, and it's going to take you a while to copy this down, but you need it for your notes. So we're looking at the rules of divisibility. First of all, you know that something is divisible by 2 if it has the last digit of 0, 2, 4, 6, or 8. Also, another way of saying that is as long as it's even, it's divisible by 2. So let's look at this number, 5,892,796. We know that that is divisible by 2 because it ends in a 6, and 6 is an even number. So that for sure is divisible by 2. Second of all, well, actually, let's go to the next one. Number 3. We know that a number is divisible by 3 if the sum of the digits is divisible by 3. What I mean by that is that means we would add all the digits together. So if I take 5 plus 2, that's 7. 7 plus 3 is 10. 10 plus 4 is 14. 14 plus 1 is 15. So that final number, after adding them all together, is 15. Is 15 divisible by 3? Yes, it is. 15 divided by 3 is 5. So this is divisible by 3. Let's look at being divisible by 4. The last 2 digits of a number is divisible by 4. So on this one, for 3,947,136, all we need to look at is the number 36 and think, is this divisible by 4? If it is, then the whole number is divisible by 4, and 36 divided by 4 is 9. So yes, this is divisible by 4. For the number 5, the number ends in a 0 or a 5. So anything that ends in 0 is divisible by 5. If it had ended in 5, that also would have worked. For 6, the number has to be divisible by both 2 and 3. So we have to go back and look at rules for 2 and 3 for 6. Both of those have to be true in order for it to be divisible by 6. So let's look at 954. To be divisible by 2, it has to end in an even number. And it does. 4 is an even number, so it's divisible by 2. Now, we need to see if it's divisible by 3. If we do that, we're going to add each number together. So 9 plus 5 is 14, and 14 plus 4 is 18. Is 18 divisible by 3? Yes, it is. And so, therefore, because it's divisible by both 2 and 3, it will also be divisible by 6. Look at the number 8. We are going to say that the last 3 digits that form this number right here, if this is divisible by 8, it will also be divisible by 8. So let's look at that. Does 8 go into 8? It does one time. So if I subtract that, and then I have, if I bring down the 3, I know that 8 doesn't go into 3, but it goes into no time, so I can bring down the 2. 8 goes into 32 4 times. So 832 is divisible by 8 by 104 times. And being that it is, this entire number, 593 million, this whole number is also divisible by 8. Alright, so let's look at 9 and see if 9 is divisible into a number. And we know that it is when all the digits add up and are divided by 9. This is very similar to 3. You notice that 3 really is related to 9 because 9 divided by 3 is 3. So let's look at this one. We have 5 plus 3 is 8. 8 plus 4 is 12. And 12 plus 6 is 18. Is 18 divisible by 9? Yes, it is. So this entire number is also divisible by 9. Now 10 is really easy because you're always looking for the last digit to be 0. If it is 0, then it's divisible by 10 no matter what. 12 is kind of like the number 6 because you're looking for them to be divisible by both 3 and 4. So once again on this one you're looking for 3 to go into it and 4, and if they both do, then it's divisible by 12. So remember, for 3 we have to add up all the numbers to see if it's divisible by 3. So let's do that. 6 plus 1 is 7, plus 4 is 14, 7 plus 4 is 11, plus 6 is 17, plus 8 is 25, 26, 26 plus 7 is 33, and 33 plus 6 is 39. Is 39 divisible by 3? Yes, it is. Okay, now we know it's divisible by 3, but we want to look at the last 2 digits and see if that's divisible by 4. So does 76, is that divisible by 4? Well, 4 goes into 7 one time. 4 times 1 is 4. So we have 36, and does 4 go into 36? Yes, that's 9 times. So we know that it is also divisible by 4. So yes, this number, this whole entire number is divisible by 12. So now what I want you to do is to see if these are true using the rules that we just did and check to see if they work. So take a moment to pause the video and come back and check. So here, if you check your work, you'll notice that 4 does not go into 3,754,086. So that's a no, because we looked at the last 2 digits. Number 2, we know that this is divisible by 9 because if we add all the digits up, we get the number 36, and 36 does divide from 9. And on this one, 677,840 is divisible by 8 because we took the last 3 digits, and that is divisible by 8. And finally, on number 4, we needed to check if 2 and 3 go into it for the number 6, and of course they both do, divided by 2 because it's an even number of 4. And if you add all the digits up, it ends up being 21, and 21 is divisible by 3. So therefore, this number is divisible by 6. Here's some more definitions that you need to know. Prime numbers. What is a prime number? It is a natural number greater than 1 that has only itself and 1 as factors. An example of this would be the number 7. Nothing goes into the number 7 except for 7 itself and the number 1. So 7 is a prime number. A composite number is a natural number greater than 1 that is divisible by a number other than itself and 1. So if I looked at the number 6, 6 is divisible by 6 and 1, but it's also divisible by 2 and by 3. Both those numbers go into the number 6. Lastly, we want to look at prime factorization. This is a way of expressing a composite number as the product of its prime numbers. So I'm going to show that in the next screen. Well, probably in the screen after this, actually. Let's finish writing our vocab down and we'll come back to that. So theorem. A theorem is a statement that can be proved using deductive reasoning. We looked at this a little bit from chapter 1, and we'll talk more about that. Here's an example of a theorem, a fundamental theorem of arithmetic. Every composite number can be expressed as a product of its prime numbers in one and only one way. So, when I ask you guys to write down the prime factorization for a number, it is actually the genetic code of that number. No other number has the same prime factorization. So, for instance, if I say, let's write down the prime factorization of 6. Well, 2 and 3 go into 6. 2 times 3. There are no other prime numbers that go into 6. So this is unique and only unique to 6, having a prime factorization of 2 times 3. We'll look at that more in just a minute. So we want to look at the prime factorization of 700. What I'm going to recommend that you do is to use a factor tree. So we'll break this 700 down, and right off the top I can tell you that 7 goes into 700 100 times. The number 7 is a prime number, so I'm going to circle it. Let's divide 100 down. 100 can be divisible by 25 and 4. Neither one of those are prime, so we can keep going. 25 is divisible by 5 and 5. Those are both prime. And 4 is divisible by 2 and 2. Those are also both prime. So I can write this as 700 equals 2, and we have 2 of them, so it would be to the second power, times 5. And since we have 2 5s, that will also be to the second power, times 7. And we only have one of those, so you can just say to the first power. So the prime factorization of 700 is this right here. And that is unique only to 700. Now, I want you to take time to stop the video and try to do the prime factorization of 120. Okay, so this is what I got for my factor tree. Your factor tree may look a little different than mine. You could have divided 120 by 2 and found some other ones, or divided by 5 right away. But as long as you end up with the same prime numbers, I had 3 2s, 1 3, and 1 5. So that is my final outcome. And if you got that in the end, then you did it right. So that is the end of this part of the video.